When Japanese engineers examined the Norden bombsight, they admitted it was 20 years ahead. When Japanese engineers examined the Norden bombsight, they admitted it was 20 years ahead. March 1945, Bandung Airfield, Java. A captured American B-29 Superfortress sits in a Japanese hangar, its silver fuselage bearing the scars of aerial combat and emergency landing. For the Japanese military establishment, this aircraft represented something far more valuable than a single reconnaissance asset or transportation vessel. Inside the forward compartment, carefully secured and heavily guarded, rests an object that would fundamentally shatter Japanese illusions about technological parity with the United States. The Norden Bombsight, an American engineering marvel that represented years of development, countless revisions, and technological sophistication that would astonish the Japanese engineers tasked with its examination. Among those assembled in the hangar that March morning was Engineer Colonel Yoshiro Yamamoto, a brilliant and respected figure within Imperial Japan's technical establishment. Yamamoto had spent decades studying American manufacturing techniques and military technology. He had observed the American automotive industry with careful attention. He had documented American industrial capacity with meticulous precision. He believed he understood American technological capabilities, yet nothing had prepared him for what he would encounter when he first laid hands upon the Norden bombsight. The story of how the Japanese came to possess this revolutionary American technology begins months earlier, in the desperate final phases of the Pacific War, when the outcome had become increasingly inevitable, despite official propaganda insisting otherwise. The Japanese military had captured several B-29 Superfortress bombers throughout the conflict, though never in great numbers. These massive four-engine bombers represented the latest and most sophisticated American aviation technology. They possessed ranges that exceeded existing Japanese aircraft by enormous margins. They carried bomb loads that devastated Japanese cities and industrial centers with terrifying efficiency. They flew at altitudes that existing Japanese fighter aircraft struggled to reach. Most crucially for Japanese intelligence specialists, they carried within their electronic and mechanical systems evidence of American technological advancement that Japanese engineers could only speculate about from a distance. The capture of a relatively intact B-29 with its bombsight apparatus represented an extraordinary intelligence windfall. The opportunity to examine American precision bombing technology would provide insights that Japanese military planners desperately needed to understand. The Norden bombsight was no ordinary bombing device. For more than a decade, it had represented the absolute cutting edge of American aeronautical and mechanical engineering. Designed by Carl Norden, a Swiss-born engineer who had emigrated to America and established his company in Manhattan, the bombsight incorporated mechanical computers, advanced optical systems, and gyroscopic stabilization technology that seemed almost miraculous in its sophistication. The bombsight worked through an elaborate system of mechanical calculation that automatically compensated for wind drift, aircraft speed, altitude, and numerous other variables that affected bombing accuracy. By rotating a synchronized prism system based on the calculated angular velocity of the target, the bombsight could keep a target motionless in the bombardier's crosshairs throughout the bombing run. This revolutionary synchronous or tachymetric method represented a fundamental departure from conventional bombing approaches. It allowed for precision bombing from altitudes where enemy air defenses struggled to reach. The Norden had been classified as one of the most carefully guarded military secrets in the United States. When not flying, Norden bombsights were removed from aircraft and stored in secure vaults. Each unit carried an automatic self-destruct mechanism that would destroy the device if enemy capture appeared imminent. The security surrounding the Norden had been extraordinary. American pilots and bombardiers who operated the system were sworn to strict confidentiality regarding its capabilities and technical specifications. During briefings before bombing missions, the security protocols surrounding the Norden bordered on paranoid. Bombardiers received intense training on proper handling and care of their devices. They understood that compromising the Norden represented a potential threat to American strategic bombing operations. They recognized that foreign powers would spare no effort to acquire technical details about this remarkable system. Yet through a combination of accidents, damaged aircraft that fell into enemy hands, and the fog of war in the final chaotic months of the Pacific conflict, The Japanese had managed to obtain an intact or nearly intact Norden bombsight for technical examination. As news of this capture spread through Japanese military intelligence channels, urgent orders went out to assemble a team of the nation's finest technical experts. Engineers from the Army Air Force Technical Bureau received immediate reassignment. Specialists in optics, mechanical engineering, and aeronautical design were recalled from other projects. The examination of the Norden bombsight became a matter of paramount military importance. The technical insights gained could potentially revolutionize Japanese bombing accuracy and aircraft performance. Colonel Yamamoto arrived at Bandung Airfield with several colleagues, each a recognized expert in their particular field of engineering expertise. They brought with them precision measuring instruments, notebooks for detailed documentation, and minds prepared to understand American technological achievement. Yet they were not prepared for what they would discover. The team's initial approach was methodical and systematic, following standard protocols for technical intelligence analysis. Photographs would be taken from multiple angles. Detailed measurements would be recorded. The assembly and disassembly would be carefully documented. Sketches would be created showing component relationships and internal mechanisms. Yet as they began their examination, a transformation occurred in how they understood American industrial capacity and engineering sophistication. Colonel Yamamoto later described his first impressions in restricted military documents that survived the war and were later examined by historical researchers. When I first observed the Norden bombsight's external appearance, I noted careful attention to form following function, he wrote with evident respect. Each component bore evidence of precision manufacturing, yet it was upon beginning to disassemble the unit that my understanding of American capability underwent profound revision. The internal mechanisms revealed engineering principles that seemed almost incomprehensible in their sophistication. The mechanical computer at the heart of the Norden represented an engineering achievement that stunned the Japanese specialists. Unlike conventional calculators that required manual adjustment of numerous variables and settings, the Norden's computer automatically processed input variables through an interconnected series of mechanical linkages, rotating elements, and precisely machined components. Wind speed, wind direction, aircraft altitude, aircraft airspeed, bomb ballistic coefficients, and numerous other variables fed into the computer mechanism. The mechanical system then calculated the precise impact point without human intervention beyond inputting the basic parameters. The precision of the machining work astonished the Japanese engineers. Tolerances in the mechanical components seemed impossibly tight. Parts fit together with clearances measured in thousandths of an inch. The synchronization between different mechanical elements required precision that the Japanese had only managed to achieve through intensive hand-fitting of individual components. The American Norden incorporated such precision as a standard requirement that hundreds of units had been manufactured to identical specifications. The optical systems of the Norden proved equally sophisticated. The bombsight incorporated multiple lenses ground to precise optical specifications that provided magnification, correction for atmospheric distortion, and the ability to focus on targets from altitudes that made the target appear impossibly small to the unaided eye. The optical path through the system involved careful calculation to ensure that the viewed target would maintain its relationship to the mechanical computer calculations. The synchronization between the optical system and the mechanical computer meant that as the bombardier kept the target centered in the crosshairs through physical manipulation of the sight, the mechanical computer was simultaneously calculating the precise release point. When the bombardier released the bombs, they would release automatically at the precise mathematical moment to achieve the calculated impact point. The sophistication of this integration between optical and mechanical systems demonstrated engineering coordination and manufacturing precision that seemed almost beyond the Japanese capacity to replicate. The gyroscopic stabilization system represented perhaps the most revolutionary aspect of the entire Norden apparatus. Japanese engineers understood gyroscopes. The Imperial Navy had been using gyroscopic systems in naval fire control equipment for decades. The Army had incorporated gyroscopes into various weapon systems and instruments. Yet the Norden's application of gyroscopic principles transcended anything the Japanese had previously encountered. The bombsight incorporated gyroscopes that actively stabilized the entire aiming mechanism against the motion of the aircraft. If the B-29 bomber banked or pitched during the bombing run, the gyroscopes automatically corrected the sight to maintain its alignment with the target. This meant that bombardiers could achieve accuracy that would have been impossible with non-stabilized bomb sights. The gyroscope system incorporated feedback mechanisms that sensed aircraft movement and automatically compensated. The precision of the gyroscope manufacture represented manufacturing excellence that exceeded what Japanese production facilities could routinely achieve. Each gyroscope required grinding and balancing with such precision that the Japanese manufacturers of gyroscopic equipment simply could not match the specifications. As the Japanese engineers disassembled the Norden Bombsight component by component, a growing realization began to permeate their consciousness and their documentation. They were not examining a device that represented merely incremental advancement over current Japanese technology. They were examining something that suggested the Japanese were operating approximately 20 years behind American technological development in certain critical areas of military technology. This realization was psychologically devastating to military specialists who had prided themselves on understanding American capabilities. The implications extended far beyond the bomb sight itself. If Americans possessed the precision manufacturing capability to produce hundreds of identical Norden bomb sights, what other technologies were they producing with comparable precision? What other areas of military equipment might be ahead by similar margins? Could Japanese industry possibly close such a technological gap? The assessment that emerged from the technical examination was brutally honest in its pessimism. Colonel Yamamoto documented his findings in reports that ascended through the Japanese military hierarchy, reports that made clear the fundamental disparity between American and Japanese industrial capabilities. The manufacturing precision evident in the Norden bomb sight reflected American industrial organization and quality control practices that existed at scales and with consistency that Japanese manufacturers simply could not match. American factories were producing these devices in quantities that suggested standardization and quality control protocols far exceeding anything existing in Japanese manufacturing. The precision machining required for the Norden components depended upon American access to materials of consistent quality and manufacturing machine tools of exceptional capability. The Japanese military specialists understood that these prerequisites represented not merely technological differences, but systemic differences in industrial organization. The realization that American manufacturing could achieve such consistency and precision suggested that American production capacity in all military equipment categories probably exceeded Japanese capabilities by correspondingly large margins. For a military establishment already facing overwhelming industrial disadvantage, this realization carried implications that were intellectually paralyzing. One particular discovery particularly shocked the Japanese technical team. The ball bearings utilized in the Norden bomb sight demonstrated manufacturing tolerances and precision that seemed almost supernatural to the engineers accustomed to Japanese manufacturing standards. Ball bearings represented a critical component in numerous military and industrial applications. Their precision and durability directly affected the performance of virtually every complex mechanical device. Japanese manufacturers had long struggled to produce ball bearings with precision sufficient for advanced aircraft engines and fire control equipment. The ball bearings in the Norden bomb sight suggested that American factories had solved this problem comprehensively and could produce bearing sets in volumes sufficient to equip hundreds of bomb sights. The implication was staggering. If American manufacturers could achieve such precision in such mundane components and produce them in such quantities, what did that suggest about American capability to produce advanced aircraft engines, shipboard weapon systems, and all the other military technologies that depended upon precision bearings and similar precision manufactured components? The documentation of the technical examination consumed weeks of intensive work. Japanese engineers photographed every component. They produced technical drawings attempting to capture the design specifications. They recorded measurements and specifications with meticulous precision. They documented their observations and analysis in detailed reports that attempted to convey to senior military and government officials the implications of what they had discovered. Yet they recognized that their detailed technical analysis could not adequately convey the fundamental realization that had emerged from handling and examining American equipment directly. The American engineering was not merely different from Japanese engineering. It represented advancement in fundamental capabilities that Japanese industry could not hope to replicate without transformation of industrial organization at scales that seemed impossible to achieve during wartime. A particularly astute Japanese observer might have recognized that the Norden Bombsight represented not merely advanced technology, but advanced technology produced at industrial scale and with consistency that reflected deep confidence in manufacturing capabilities. Only industrial establishments of extraordinary sophistication could maintain such quality control standards across hundreds of individual units, while simultaneously producing thousands of complete aircraft, engines, and all the supporting equipment required for military operations. The American approach to precision manufacturing that the Norden Bombsight exemplified had not emerged spontaneously or by accident. It reflected decades of industrial development, investment in manufacturing infrastructure, training of skilled workers, and development of engineering practices that had become systematized within American manufacturing establishments. American automobile manufacturers had pioneered mass production techniques that prioritized consistency and interchangeability of components. These same principles had been systematized and expanded within American military manufacturing as the nation mobilized for total war. The Norden Bombsight represented the application of these systematized manufacturing practices to precision military equipment. Its existence in the quantities that American production could maintain suggested that American industrial mobilization had achieved integration of precision manufacturing principles into military production at scales that Japanese industry had never attempted. Colonel Yamamoto's subsequent reports to Japanese military headquarters conveyed the technical specifications of the Norden Bombsight with accuracy and precision. Yet they also conveyed a sense of professional despair regarding the implications for Japanese military capability. The technical analysis documented that the Norden Bombsight could maintain bombardier's ability to keep targets centered in the aiming mechanism, even when the bomber was flying at altitudes exceeding 30,000 feet and speeds exceeding 350 miles per hour. The mechanical computer would calculate the precise release point based on all relevant variables with mathematical certainty. The automatic release mechanism would then release the bombs at the precise calculated moment. The result was bombing accuracy that American military planners had theoretically calculated could reduce bombing patterns to as little as 75 feet. Circular error probability from bombing altitudes that should have been safe from most existing air defense systems. The strategic implications were profound and terrifying to Japanese military planners who understood that such bombing accuracy applied to Japanese industrial facilities could result in devastation that conventional bombing had not yet achieved. The contrast between the Norden Bombsight and Japanese bombing equipment available to their own Air Force only deepened the sense of technological disparity that the examination revealed. Japanese bombers relied upon conventional bomb sights that required the bombardier to visually identify the target and manually calculate bombing parameters. Japanese bombing accuracy was largely dependent upon individual bombardier skill and luck regarding atmospheric conditions and aircraft stability during the bombing run. No automated calculation system provided the mathematical certainty that the Norden Bombsight offered. No gyroscopic stabilization system maintained bombardier accuracy regardless of aircraft motion. No mechanical computer processed the complex variables that affected bombing accuracy. Japanese bombing equipment represented engineering approaches that dated conceptually to the previous generation of military technology. The realization that American technical personnel had possessed the confidence and capability to build precision bombing equipment representing fundamentally advanced engineering principles suggested that the wider gap between American and Japanese military technology extended far beyond aircraft and bombing systems. If Americans could build the Norden Bombsight, what did their radar systems look like? How advanced were their communications equipment? What level of sophistication had American naval fire control systems achieved? What did American fighter aircraft incorporated in terms of technological advancement that Japanese aircraft could not match? The psychological impact of these questions upon the Japanese military technical establishment cannot be overstated. The examination of the Norden Bombsight had not merely provided technical specifications for one advanced piece of military equipment. It had provided evidence of systematic technological advancement across American military industries that suggested Japanese capabilities were fundamentally outmatched. The reports generated by the technical examination were circulated through Japanese military headquarters at a time when the strategic situation had become increasingly desperate. Japan was losing the war despite official propaganda insisting otherwise. American bombers were conducting increasingly frequent raids upon Japanese cities and industrial targets. American forces were advancing across the Pacific with systematic determination. The U.S. Navy had achieved naval superiority that made it impossible for the Japanese Navy to challenge American operations. The American Army was preparing for invasion of the Japanese home islands. Military and political leaders faced the reality that Japanese victory had become impossible. In this context of strategic desperation, the technical assessment provided by the examination of the Norden Bombsight carried additional weight. Not only was the United States technologically superior in specific weapon systems, the systematic nature of American technological advancement suggested that no amount of Japanese sacrifice, determination, or courage could overcome the fundamental industrial and technical advantages that the Americans possessed. The examination of the Norden Bombsight had provided evidence that the American military-industrial system had achieved a level of technological sophistication and manufacturing capability that Japanese industry could never match. The precise details of how the B-29 carrying the Norden Bombsight had fallen into Japanese hands remain somewhat uncertain, as the chaos of the final months of the Pacific War obscured many details. The aircraft may have been damaged during bombing operations and forced to land on territory still controlled by Japanese forces. It may have crashed and been recovered substantially intact. Alternatively, it may have been captured at an airfield that Japanese forces temporarily controlled during their desperate attempts to resist American advances. Whatever the precise circumstances of capture, the American B-29 and its advanced bombsight had provided Japanese technical specialists with direct evidence of American technological advancement that intelligence reports and theoretical analysis could never convey as effectively as direct physical examination. The implications of the Norden Bombsight examination extended beyond purely technical considerations. The mere existence of such advanced American military equipment provided evidence that the United States possessed not merely greater industrial capacity but fundamentally different approaches to military technology development. American military planners had invested enormous resources in developing precision bombing capability based on the theoretical premise that strategic bombing could decisively influence the course of warfare by destroying the enemy's capacity to wage war. This strategic theory had generated demand for precision bombing systems like the Norden Bombsight. The American industrial establishment had then responded to this demand by developing manufacturing capabilities and precision engineering systems capable of producing such equipment in quantities sufficient to equip the entire American bombing fleet. The combination of strategic theory, willingness to invest resources, and industrial capability to execute produced the Norden Bombsight as a practical manifestation of American military thinking and American technological achievement. Japanese military planners, confronted with evidence of American technological sophistication represented by the Norden Bombsight, and recognizing the military implications of such equipment, faced the realization that they were engaged in a conflict with an adversary that possessed fundamental advantages that could not be overcome through conventional means. American bombers equipped with Norden bombsights could conduct precision bombing operations that Japanese air defenses were increasingly unable to prevent. Japanese cities and industrial facilities would become increasingly vulnerable to devastating bombing raids. The Japanese population would suffer increasingly severe air raids that conventional Japanese air defenses could not prevent. The Japanese military establishment could not produce military equipment of comparable sophistication to what American manufacturing could routinely produce. The strategic situation was fundamentally and irreversibly adverse to Japanese interests. By the time the technical examination of the Norden Bombsight had been completed and documented, the course of World War II in the Pacific had become definitively settled. American forces had secured territory from which massive bombing raids upon Japan could be conducted with relative impunity. American military planners had committed to utilizing strategic bombing as a major component of their strategy for ending the war. The Norden bombsights equipped the B-29 Superfortress bombers that would conduct these raids. The bombing campaign would become increasingly intense and devastating. American bombers would strike Japanese cities and industrial targets with increasing frequency and destructive effect. Japanese air defenses would prove inadequate to prevent these bombing raids. The Japanese population would endure months of intensive bombing that would destroy vast portions of Japanese cities and kill hundreds of thousands of Japanese civilians. The bombing would destroy Japanese industrial capacity and disrupt Japanese economic systems. The combination of strategic bombing, American military advances in the Pacific, and the realization that the war had become unwinnable would ultimately drive Japanese military and political leaders toward accepting defeat and seeking terms for surrender. The specific contributions of the Norden bombsight to the ultimate outcome of the war cannot be precisely quantified. The bombing campaign would have proceeded with less precision if the Norden had not been available, but bombing would still have occurred. Yet the precision bombing capability that the Norden bombsight provided represented a qualitative advantage that contributed measurably to American military effectiveness. The ability to conduct bombing operations with relative accuracy from altitudes that Japanese air defenses struggled to reach provided American military planners with options that would have been impossible without such capability. The Norden bombsight contributed to American victory through its direct military application, but it also contributed through the insights it provided regarding American industrial and technological capabilities. For Japanese military leaders evaluating prospects for continued warfare, the evidence of American technological sophistication represented by the Norden bombsight reinforced the growing recognition that the war had become unwinnable. The examination of captured American military equipment became a somewhat tragic aspect of Japanese military intelligence operations during the final months of the war. Japanese technical experts continued to examine captured American aircraft, engines, weapon systems, and equipment. They compiled technical assessments documenting American technological achievement. Yet these technical examinations increasingly carried an undertone of desperation. The technical experts were examining evidence that their nation possessed inadequate industrial and technological capacity to overcome the American advantages. The technical examinations generated documentation of American technological achievement, yet this documentation could not generate the industrial capacity, raw materials, or manufacturing capability necessary to produce comparable Japanese equipment. The gap between understanding American technology through technical examination and possessing the capability to replicate or counter that technology could not be bridged in the remaining months of the war. Colonel Yamamoto survived the war and lived into the post-war period. He witnessed the American occupation of Japan and the transformation of Japanese industry that would follow. He lived to see Japanese manufacturing ultimately achieve the precision and sophistication that had seemed impossible during the wartime examination of the Norden bombsight. The post-war economic miracle that transformed Japan into a major industrial power would not have seemed impossible to Yamamoto had he understood that Japanese manufacturers would eventually develop the industrial practices, quality control systems, and manufacturing infrastructure necessary to achieve precision manufacturing on scales comparable to or exceeding what American manufacturers had achieved during the war. Yet in the March of 1945, when he was examining the Norden bombsight in the Bandung hangar, such future achievements seemed impossible. The technological gap seemed unbridgeable. The American advantage seemed permanent and insurmountable. The Norden bombsight examination represented a crystallizing moment in Japanese understanding of the technological gap, separating their military capabilities from American capabilities. The examination confirmed what Japanese military planners had increasingly suspected, but had been reluctant to fully acknowledge. The United States possessed not merely greater manufacturing capacity, but fundamentally more advanced manufacturing practices and engineering sophistication that translated into military equipment of capabilities that Japanese manufacturers could not match. The Norden bombsight existed as tangible evidence of American achievement. The examination of this equipment could not be dismissed as propaganda or exaggeration. The physical reality of the Norden bombsight, the precision of its manufacture, the sophistication of its design, and the implication that American industry could produce hundreds of identical units all combined to create an undeniable reality that American military technology had achieved advancement that Japanese technology could not match. The ultimate fate of the examined Norden bombsight remains uncertain. Like much of Japanese military documentation and equipment, it was likely either destroyed or captured during the chaotic final months of the war and the immediate aftermath of Japanese surrender. American occupation forces and intelligence specialists would have been interested in recovering and examining any Norden bombsights that had fallen into Japanese hands. The technical examination conducted by Japanese engineers would have been of interest to American intelligence specialists seeking to understand how effectively Japanese technical personnel could analyze advanced American equipment. The Japanese technical reports documenting the examination of the Norden bombsight might have been captured and examined by American technical intelligence specialists. Yet the specific fate of this particular Norden bombsight and the original Japanese technical examination documentation remains unclear in the historical record. What remains clear is that the examination of the Norden bombsight provided Japanese military and technical specialists with profound insights into American technological capability. The examination confirmed that the technological gap separating American and Japanese military equipment extended across multiple categories of military hardware. The examination demonstrated that American manufacturing practices had achieved precision and consistency that Japanese manufacturers could not match. The examination suggested that this technological advantage extended across American military industries broadly. The examination reinforced the growing recognition among Japanese military leaders that the war had become unwinnable against an adversary possessing such fundamental advantages in industrial capability and technological sophistication. The Norden bombsight examination represented a moment of technological truth for Japanese military specialists confronting evidence of American achievement that their own nation could not match and could not overcome through conventional means. The Norden bombsight story illustrated broader patterns of technological development and military advantage during World War II. The nations that possessed industrial capacity to develop advanced military technology and manufacturing systems capable of producing such technology in substantial quantities achieved military advantages that opponents could not overcome through courage, determination, or tactical skill. The United States possessed the capacity to develop revolutionary military equipment, like the Norden bombsight, and produce it in quantities sufficient to equip the entire American bombing fleet. Japan lacked the industrial capacity to replicate or effectively counter such technology. The disparity in manufacturing capability and technological sophistication represented one of the fundamental inequalities that determined the war's outcome. The Norden bombsight examination crystallized this reality for Japanese technical specialists who examined the device and understood its implications. The precision manufacturing and mechanical sophistication embodied in the Norden bombsight represented American engineering achievement that would resonate across subsequent decades. The bombsight demonstrated that American industrial designers and manufacturers could integrate complex mechanical systems, precise optical components, and sophisticated gyroscopic stabilization mechanisms into a unified system capable of achieving remarkable precision bombing from altitudes that had previously been considered safe from enemy bombing. The Norden bombsight contributed to American strategic bombing operations throughout the war and represented technological achievement that would influence American military thinking regarding precision bombing and technological solutions to military problems for decades following the war. The examination of the Norden bombsight by Japanese engineers in March 1945 provided the historical documentation of how technologically sophisticated American equipment appeared to observers who encountered it directly and recognized its implications for military competition. The story of Japanese engineers confronting the Norden bombsight and acknowledging it represented 20 years of technological advancement beyond current. Japanese capability remains a poignant historical moment. It represents the moment when Japanese military specialists directly confronted evidence of American technological superiority and understood that no conventional military response could overcome such fundamental advantages. It represents the moment when the abstract understanding of American industrial capacity transformed into concrete recognition through direct examination of specific military equipment. It represents the moment when Japanese technical specialists understood that their nation faced not merely a more numerous enemy, but an enemy possessing fundamental advantages in technological sophistication and industrial capability that military courage and determination could not overcome. The Norden Bombsight examination in March 1945 represented one of those rare historical moments when technological reality intersected with military strategy and provided evidence that helped drive military and political leaders toward recognizing the necessity of ending the war through negotiated surrender rather than continuing a conflict that had become clearly unwinnable.